So we're going to go through cosine law, and specifically in this example, we're only going to solve for a side. We'll do another example where we solve for an angle. Okay. Now, cosine law is broken into three formulas that are all pretty much identical. When solving for cosine law, we put the side, which is what we're going to do in this example, or if you're solving for an angle, at the very beginning or end. So if you were looking for side A, you would put A on the outside and angle A. If you're solving for side B, B on the outside and angle B, and C, side C and angle C. And then you fill in the other positions, okay, with the variables that aren't as important. Well, I'm going to put like a skeleton model, and we'll even put, say, X is what we're looking for. It'll be equal to the other side squared plus the other side squared minus 2 times another side cos angle X. Okay, so really we're just filling in those blanks with any of these three formulas. Now it's also important to realize that with a triangle, I know I kind of overlapped here, but our angle B is always opposite of side B, angle A and C and C. So that pattern has to be true when we go to fill things out. Okay, so let's say in the first example, we've been given a triangle. This triangle here is an angle of 62 degrees. This will be 9 meters, and this will be 3 meters. Okay? And let's say they've actually called it RST. Okay? Well, in our formula, we have two choices. We can rename this triangle, and then, of course, let's say they're looking for us to solve side T. Apologize, I need to put that in. And whatever side would be side T, we would choose that formula. So if we renamed it so that, let's say, C was here, we would use this formula here, where side C is on the outside and angle C is there. Okay? But instead, what we're going to do is, instead of renaming it, we're going to try to just apply it to this blank formula here. Okay? So I'll rewrite one of the versions, and then we're going to talk about how we've written information in. So here's one version where C squared is equal to A squared plus B squared minus 2AB times cos C. Now remember, the C's are what we're looking for. In this case, we're looking for T. So this becomes T squared is equal to, and then we just choose the other two sides. It doesn't matter what side is which or what order. We just have to fill in our A and our B. So that leaves us with R and S. Okay, so we're going to write those actual letters in. R squared plus S squared minus 2RS times cos, and then this has to be, just like our original, angle T. Okay, it has to be opposite of the side. Here we're going to fill in all our information. We're still looking for side T, which is squared. Side R, which is opposite of angle R, is 3. Side S, which is opposite of angle S, is 9. Minus 2 times 3 times 9. And angle T is 62 degrees. Okay? So we filled in all of those letters. The goal is isolate just for T. So we really work on the right side of this equation, simplify everything there, and then we'll square root it at the end because we have to isolate for T. So let's try to go through this. T squared is equal to 3 squared is 9, 9 squared is 81. Negative 2 times 3 is negative 6 times 9 is negative 54 times cos 62. So this is where a lot of students make an error. They see 9 plus 81 minus 54 and they equate all of them. We can't do that because according to BEDMAS we deal with multiplication first. And really this says negative 54 times cos 62. So we have to actually equate this part first. We'll equate this part. So we'll get T squared is equal to 9 plus 81. And we'll take out our calculator here. No, not 9 plus 81. What is it? Sorry? So positive 36. Are you sure? Let me try that myself. So let's do 62 cos times 54 when it's negative. Negative 25.3. That's okay. Oh, make sure it's in degrees, guys. What did we say? Negative 25? check it. Yeah, negative 25.35. Okay. So that is what negative 54 times cos 62 is. We just equated that. 9 plus 81. Jerry? 90 minus 25.35. T squared. Take our 90, subtract 25.35. Oh, that didn't work. 90, subtract 25. Why is it not working? 25.35. 64.65. Are we done? Is that what the length of that side is? What do we still have to do? Square root. These two will cancel. T equals, in the root of 64, 8.04, which we're going to equate to T is approximately 8. So side T on this triangle is approximately 8 meters